Hey guys, this is Nirav Kaku, and today's video is about integrating the Deepstack Docker container with our Delphi application. There's going to be three sort of parts in this video. First part will be about how to and where to get the Docker container from and how to install it, configure it. That part of the video is going to be relatively short because there are tons of other great videos out there that you can refer to. So it's more just of an indicative thing that you need this and this needs to be installed, and we're going to be verifying to see whether the Docker container is running correctly or not. The second part of the video will be a demonstration, which basically will show you the code that has been written that trains the DeepStack Docker container to recognize a face. Then, of course, we give it another different face and actually figures out who that person is. And the third part of the video, which is probably going to be the longest, will be about the code explanation that we need to basically write to integrate this service. At the end of this video, you'd probably have a local AI training service for face recognition, using Delphi. And yeah, I hope you guys have fun with it. Cheers.
Okay, so let's get started with installing the Docker image and running its container first, because that's the first thing that you require. So I've got my Docker desktop set up here. I'm going to go ahead to the images, and I'm going to go ahead and search for DeepStack, and I found it. Now it already says run here because I've already gone ahead and sort of pulled it. But in case you haven't pulled it, it will give you a pull option, an install option, whatever you like to call it. And once you do that, it's going to give you this play option, right? Which is basically you can then create a container from it. Once I have it, I'm going to go ahead and close this window. And it's going to show up here in my images. And once I do that, I can hit the play button here. Okay, and moment I do that, it's going to give me the options to set up the new container. Now it is important that you actually give some of these options if you want to use all the functionality that comes with DeepStack. It doesn't switch them on automatically. Let's go ahead and start. Let's call it Delphi DeepStack. Maybe it doesn't like a space in between. And I'm going to go ahead and post path. I'm going to select a local folder. In my case, I'm just selecting one folder that I have created for it. And it will map to the data store folder on the DeepStack container. And now I want vision face to be on. I want that service, and I want vision detection also to be on. And just for the heck of it, I'm going to add one more service called vision seeing, which also I need. Now, once you have this, you can actually go ahead and run it, and you can see what happens, right? When you run your container, it gives you this log. This basically confirms that all these APIs are now available to be accessed via the software that you're going to write. Okay, so this is the important part about Docker configuration. Once you have this running, you can pretty much close this, and the rest of this video will now be how to use this in Delphi. It's time to basically write some sort of a UI to interact with our with the Docker services. The UI is basically going to be using the wrappers that I've written for the Docker container for face detection. But and after that, we will we will go into the code explanation how the wrappers work. So for the UI, I'm going to go ahead and I've already created a project called Deepstack. I'm going to go ahead and add new multi-device form, which is perfect. And let's just say that I want to put an edit box here. And I'm going to add a label to that edit box. Okay. And this label will be basically the user ID, right? So the thing is, I'm preparing it for recognizing and identifying the user. So I need to basically train, and so this is the user ID, and I'm going to create one more label in which I'm going to give the image file. I'll just put it here, and text. Let's call it the image file, and let's also add an open dialog box. And just extend this a little bit. Add a button. Let's call it name. Button choose file. And let's give this text. Choose file. All right. And what we are going to do is when we click this, you're going to have open dialog box execute. Right. It's true. Then again end. And what I'm going to do now is I'm going to use the wrapper that I've written, which is this file. We'll use classes.deepstack. I didn't want to. The reason, if you guys are wondering why it has Z instead of S, is I didn't want to use classes just to avoid any conflict, right? Because there's a lot of places in the RTL where classes is written, so I just changed the name for for being cautious. So and now I can start using one of the classes that I've created. So let's just say go ahead and create a variable, and I'm going to call it of type Deepstack for face, right? And maybe I can just sort of go ahead and create it. Create, and it'll ask me for my server. Now, this server address is basically the server on which my container is running, which in this case is localhost. And what is the port that it is running on? So I'm going to go ahead and put the port, and I'm going to go ahead and also put what version. Yeah, in my case, we have used version 1. Now, if you are not sure, we can reconfirm. I'll go ahead and open my containers, and you can see that we had created this container Deepstack, and I'm going to go ahead and run it. And the moment I run it, I can, open in terminal, and the log says V1 vision. And if you remember, we had given this port 5000. So that's the reason we choose 5000 here, and V1 is because this has got V1 here. Alright, so this kind of sets us up. If there's a V2, then all you have to do is choose v2 here at a later date, and it should work. So you've gone ahead and created a class. Now let's go ahead and say, and now you can go ahead and train it. So let's say whatever the value of edit. Not sure. This is, let's just give it a name called EDT user ID, and this EDT training file name. And what we want to do is we want to, give it the user ID. So we go ahead and put it as EDT user ID dot text, and what is the file that you want to train with, and we go ahead and EDT training file dot text, and that's it. And the train is a function that gives boolean. So if you say if it's true, then let's go ahead and maybe even add a memo, and let's write this and go ahead and say memo1 dot lines dot add user ID has been trained with this successfully else we can just say error in training. Okay, and let's just go ahead and see if this works. Oh, sorry, what did I do? If it's execute, then what we want to do is, alright, EDD. Okay, so what we've done is we've written this code, and this code is only for training. So let's go ahead and run this application and see what happens. Now here I'm going to go ahead and give my user ID, and let's say Modi. Modi is our Prime Minister, so pretty easy to find images of him. That way at least I know I'm not violating any privacy issues, because he is a public figure. I'm going to choose a file, and let's see, and here are all the images. So I'm going to take his first image and I'm going to start training the model, right? So I'm going to use his first image and I'm going to say open, and as soon as I do that, it has been trained successfully. So it actually worked, right? Basically means that this function trained the face recognition system successfully. Now let's go ahead and train it a little bit more. I'm going to go ahead and use this, and it has accepted the second image. I'm going to go ahead and do the third image, fourth, fifth, and sixth. Okay, so far we have successfully trained our face recognition AI model with 6 images of Prime Minister Modi. And now what we'll do is we'll write code to identify if Modi is in the photograph, yes or no. Okay. So I've now stopped the application and I'm going to start writing the code for recognition. And for the recognition code, I basically again want uh, a file name that the user will choose. Okay. And what I want to do is I want to display it in the image. Okay, there you go. So, and in this image, I will try and identify exactly where is the face that it is recognized and what is the user ID. Okay, so let's name this to EDT recognize image file, image path. Let's change this to btn recognize. Since I've copied it, I want to make a new click, and of course I'm going to use the same code, and instead of EDT I will make it as recognize.text, right? And again I'm going to be using the same variable here. I just realized I should have probably done always a good practice to do this. And then what I want to do is I want to write ft dot, and I've got this recognize, and in that I'm going to say edit text, right? And you can see it gives me a face recognition response. So I can call where r, which is response, is equal to this, and r dot, you can say success. So if r dot successful, then what I want to do is r dot face data, and I've got an array of face data records. This is because sometimes a photograph can actually have more than 2 or 3 recognized faces, but in this case we'll just go with the first one that is there, and in that we have our user ID, the confidence, and what part of the image has the face been recognized in, right? So what I'm going to do is quickly sort of give this information in a memo box. So let's go ahead and put a memo here once again, and let's just see what happens, right? We go ahead and say 2 dot lines add and face data dot user ID, which is string, no problem. And let's see if we can add some more stuff in it. What is the confidence level? So let's go ahead and put user ID is this, confidence is this, and let's see what happens. So let's go ahead and just do a quick run to see what happens if we run this application. Let's run it. And let's choose a file. Okay, so remember we had used the first 6 images to train, and now we want to use this image to see if the model actually recognizes. And let's choose this. And you see, it has responded that the user ID is Modi and its confidence level is 64, which is greater than 50%, which is not bad after recognizing only 6 images. Uh, so yeah, it seems to be working. Now let's add some more information in it. Let's go ahead and see if we can position, and let's go for the top. Okay, now let's run this again and see what happens. Now what we are trying to do is we want to see what part of the image is the recognized face in. And here you can see that it has given us this location. So let's see if we can, sort of do something to highlight that part, right? So let's go ahead and image one dot bitmap dot load from file. Let's do this so that we know that the file will load up the file in the image. And then what we want to do is we'll try and highlight. So I've got this code that is ready, and I'm going to go ahead and see if I can highlight the image. Let's run this. Take this, and there you go. It actually ended up highlighting the location where it found Prime Minister Modi. And yeah, that's it. So it seems to be working. In the next section, we will talk about the wrapping code that I have written. So now let's get into the explanation of the code that actually makes this whole thing work. Let's go ahead and start with the base class. So what I've done is I've created a unit which has got all this implementation. I've kind of put regions around the unit to make it look a little neat, so that all the code is not there in your face right at the same time. So let's see what I've done. So this is the basic DeepStack base class, and you can see that it starts with simple DeepStack4D class, and in that we've got an HTTP client and a HTTP request, and basically these are the components that are going to be making the calls to the DeepStack container that we've run. So this is the class in which the server address is initialized along with the version. And if you sort of go to the implementation of it, you can see that all I'm doing is making sure that the client requests are created and the DeepStack server address is initialized as per the parameters, and that's it. That's all we are going to do in this, right? So it's pretty much only holding the address of the server and the version, right? Now, from this class, I have gone ahead and inherited another class called vision. So the reason this hierarchy is there is because the DeepStack container actually has services, and the face service actually is a layer below the vision service, right? Logically. So we've got the DeepStack container. In that, there is the vision service, and in vision, there is a face service, right? Because a vision can have an object detection, a vision can have a face recognition, a vision can have some other kind of action detection also, right? So vision is a sort of a layer, and then from that layer, there are these more specific vision-based services like face detection. So the first abstraction is on the vision level, and all I've done is done nothing, but I've just sort of created an abstract layer, and it really does nothing other than the fact that it sets the domain. And if I go to the implementation of this constructor, all it does is it inherits the parent constructor, and sets the server address and version. And in addition, it also defines the domain. That's basically it for this particular abstraction, right? Now, the final part is basically the face detection and the face training APIs, which inherit from the DeepStack Vision class. And again, you can see the constructor is pretty much the same, where you give the server and the version. The domain is going to be set automatically by the parent class for this, the final class, which is our face class. And then we've got two functions in that. One is basically to train the model, and one is to recognize. And now, if you actually see the implementation of this class, the constructor calls the parent create, which in turn will call its parent, which is fine. And the function that we've given here is a function called face. Now, all of this actually comes together in the implementation of the API, which calls the actual API. And these are just some validations. What I'm doing is I'm actually constructing the API call dynamically. In our case, the first construction is the base server, and in that we are adding the version, and in that we are adding the domain. So imagine this would be HTTP localhost 5000, and in that version is version 1. Domain would be vision, function would be face, and then finally to train, the final endpoint is register. And then what we do is we send the data that the register API takes. One is basically we add the file that the user has given us. You can see which comes in the parameter, and what is the user ID, who does the face belong to. And all we do is call a post, and if the response is correct, then what we do is we try and see if the registration was successful, and in the end we free all the objects that we had used to make the call. It's really straightforward. It's not complicated at all. We can all this function over and over again, like I showed it in demo, and keep training the model as much as possible with different images, and give it a sense of what it needs to do. And now what we can do is move on to the recognition API, and in that we can see what it does is that we give it a file name to recognize. You can actually give it a minimum confidence level, so you can configure that, give an answer only if the confidence level for a particular recognition is above uh, 40. And you can either set it low, but I guess 40 is what seems to be a reasonable confidence level. Uh, and after a few validations, we are doing the same thing as we did for training. We are creating the URL dynamically, and this time the endpoint, instead of registered, it's recognized. And once again, we give it an image that we wanted to recognize based on its trained model. And what we are doing is we are adding a minimum confidence. In this case, it really accepts a value between 0 to 1. So I am dividing it by 100 to make it format. You post to that URL, and it gives you a JSON object back. Now, in this case, what it'll do is it will try and recognize if the image has faces and whose faces they are. Since we've trained only one face in our model, it's going to try and recognize to see if there is that face in the model. And once it does, it comes back with an answer saying in the JSON object saying that whether it had any success recognizing the image, and if it did, then it will come up with an array of predictions. And for each prediction, all I'm doing is enumerating through the JSON array and converting and sending it back as a record. I'll quickly show you what the record looks like. Is an array of face data, in which if it is recognized, and you give the user ID with the confidence level and where in the picture is where in the image is that face, and then finally we are sending this as a face recognition response, which is, like I said, nothing but an array of face data. And yeah, that's pretty much it. And now you can sort of host this service, as a private service for people to train faces, and maybe even come up with products that can recognize a user ID, and and then you can automate stuff based on what your confidence level is. Uh, so based on what you feel the confidence level the AI model is recognized at. So that's it. I hope you found this video useful. I'm going to upload the code to GitHub and probably post a link to that code in this video. So